Okay, let's rock and roll. So, question 1 for today. It says, the topic says, finding intersection points for straight lines and parabolas. Let's just start with a little multiple choice question. So here's your question. Use the graph to solve the simultaneous equations y equals 2x minus 4 and y equals minus x plus 5. So you have to use the graph to help you find the simultaneous solution, or others say the intersection point generated by these two. So over to you guys. What do you think it's going to be? Oh, that's good. Yes, we are. Although trig always comes back. It's like in grade 11 and 12. It never goes away for too long. So as we look at this question, maybe someone can tell us, what's the relationship between a graph and an equation? Like what are we looking for? Where are we looking? It's often helpful to share our thinking. How are we connecting solving the simultaneous equation with the graph? Where the graphs are equal, yes, or where the graphs cut each other, what we call the intersection point. So the intersection point of two graphs will be the simultaneous solution. It's where their x and their y are equal. So wherever that x is and whatever that y is will be the answer that satisfies both of these equations at the same time or simultaneously. And from what I can see on the graph, this so 1, 2, 3, x should be a 3 and y should be a 2. Or in coordinate form, the answer should be 3, 2, or x is 3 and y is 2. And as I look at the answers, I see that it could be B or it could be C. Both of those are correct because they're different ways of saying the same thing. Okay, give me a thumbs up if you understood the question, because this is going to be what tonight's lesson is around, this idea of having two functions, finding their simultaneous solution, finding their intersection points, and we want to make sure that, okay. So a couple of in-betweens, and then, all right, well, let's do a second one like this. But so I want to find the simultaneous solution, or find the intersection point of y equals x minus 5 and y equals minus x squared plus 1. But before we even start solving it, what is different about this question compared to the last one? So put your hand up or pop it in the chat. What is different about asking for the simultaneous solution of these two graphs, or an equivalent ways to find the intersection points of these two graphs? But what's different about this? So there's a parabola. Yep. So this one over here is a parabola, and this one is a straight line. So there's two types of different functions involved this time. Yeah. Okay, now what is the simultaneous solution or solutions to where of y equals x minus 5 and y equals minus x squared plus 1, which is what the graph is showing? Pop your answers in the chat or pop your hand up if you want to share your thinking or willing to share your thinking. Let's see. Okay, so Flamelo is saying 2 minus 3. So let me go to 2. Here's 2. Oh, here we go. So Flamelo has found this intersection point and said, look, I can see that that coordinate is 2 minus 3, or I could say that's one of the solutions or intersection points. Now, what about another one? Ongani agrees. Ongani, I agree with you too. But I think maybe that isn't the only one. I feel like there's another place where the two straight lines meet each other. And Tocorzo says I should go look at -3. So where's -3? Here's -3. Oh, there we go. So it looks to me like the other intersection point would be -3 -8. Or we could say x is -3, y is -8. Now, you are very much correct that these are the intersection points or the simultaneous solutions to these two. But we don't always have the luxury of having a graph. Sometimes we need to use algebraic methods. And so let me show you an algebraic method for finding the equation, finding the intersection points, because sometimes when you don't have a graph, you have to use this. So we can use something called substitution. And what we do is we take the easy equation, which is this one, and we sub it into the hard one. So if I do that, I'm going to replace this y here with x minus 5 equals -x squared plus 1. And what that does is it eliminates one of the variables y by subbing in. Give me a thumbs up if you understand what I did here when I subbed the easy equation into the hard one to eliminate the variable y. Okay, do you understand what I did there? Now, if I'm telling you the truth about this, the answer that I get from the algebraic method should match the answer that I've got graphically. So let's see how I would do that. It's a quadratic equation, so I'm going to move it into standard form. So I've got x squared plus x minus 5 minus 1 is 0. And that's just by moving the terms across. And then I've got x squared plus x minus 6 is 0. Now I have two choices. I can either use the formula, the quadratic formula, or I can factorize this. Both these methods will work. For now, just because of time, I'm going to use factorizing because I can kind of see the answer. But I invite you to use the formula as needed. And so here we get x is equal to, well, let me even do it like this. I'll do both brackets. So I go x plus 3 is 0, or x minus 2 is 0, x is minus 3, and x is 2. This makes me very happy because that is what I wanted to see matching my. I want to ask though, if I've got x values of -3 and 2, how do I get the y values if I couldn't see them on the graph? Ayabonga, I'll go through this process again now, but I just want to ask, maybe someone could even come on the line. So step 1 was I subbed. Step 2 was I moved things around. Step 3 was either the formula or factorizing. But now I've got my x values. I need to get y values that go with these x values. How do I get those? Okay, so you sub x values into the formula. Actually, you can choose either formula. I'm going to choose the easier one, which was y equals x minus 5. So if I look at what was asked earlier on, y equals x minus 5 was the easier of the two equations. And so I'm going to use that. I'm going to go y equals something minus 3. And over here, y equals, sorry, not -3, minus 5. And here it's going to be something minus 5. What is that something going to be? In this case, it's going to be -3. In this case, it's going to be 2. And then we're going to get y is -8 and y is -3. And this is good news because the -3 is going with the -8, which I hoped. And we can also see that 2 minus 3 is indeed happening here. So the story of the graphical method and the story of the algebra are the same story. Now, I know there are some questions, so I'm going to just pause for a second to allow those questions to come forward. But if you followed what I did there, give a thumbs up. If you are feeling a bit lost, maybe give a thumbs down. And also, I want to ask, are there some questions from students? I'd love to answer or ask if I've lost you maybe somewhere on this journey here. I would love to answer a question if you do have one. So Humlelo has asked, can we use the simultaneous equation method to solve this? Yes, there are other methods that you can use, Humlelo, as long as you were getting the same answer, you're completely fine. Let's go and do another multiple choice question just to get, I know not everyone's there yet, but let's have a quick look at a similar type of question from before. So here is your question. It says, this is a sketch of the graphs y equals x squared minus 3x minus 2 and y plus x is 3. Use the sketch to estimate for the solution to the pair of these simultaneous equations. So basically they're saying, use the sketch here to help you find the solution or to estimate the solution to these two equations. Or another way of saying that is to say, find the intersection point of these two equations. And I'm going to give you some time to think about how to do that, and then pop your answer in the chat when you're ready. So if we look at these two graphs, it looks to me like they meet at this point and this point. And what I was saying previously is that the intersection points of two functions are the simultaneous solutions to the two equations of those functions. So all I need is a little bit of a think about what do I think that value is there, and what do I think that value is here, I guess. So if I look at this point over here, it looks to me like it's about minus 1.6 or something around there. And it looks like it would be positive 4.2 or 4.3 or something like that for that one. Now that's just the first one. Let's see if anyone's got that. Well, that does. That doesn't. Does that have? No, that doesn't. That's the other way around. So you can see, yeah, it's going to be A. Now, if I had to think about finding solutions, a good estimate would be about minus 1.4, 4.4, and positive 3.4, and minus 0.4. Those are the two estimates of the simultaneous equation. If I had to find this exactly, so we're not going to do the whole question now, but if I had to find the exact answers, I want to know from the class, what would my first step be if I was dealing with these two equations? I just had them and I had no graphs to help me. So who wants to put their hand up and help me out here? Who feels like they can share some of their immense knowledge about this process? So, yeah. Timocho, what would you do to start off with?
Hi, sir.
Hey.
Won't you start off by saying x squared minus 3x minus 2 is equal to y plus, oh, before that you have to put y as the sub of the second equation, which is going to be y equals to 3 minus x. And
you are winning at life. That is so good. Because I could see how you literally figured it out as we were doing it. Why
Yes.
did you have to why do we have to do this step? Why does it make life so much easier?
Because the first one, y, is the sub, it's like the main one, so it's going to be easier for y.
Yeah. So if you want to sub, it's not so easy to put y plus x is equal to 3 into the other equation. But if you rearrange it like this, it becomes so much easier to then say, look, it's 3 minus x equals x squared minus 3x minus 2. And then from that point, you would have to solve that equation. And that would take some time, but that's what you would do. Lovely, Timocho. Okay, well, let's keep going with this thinking, and let's ask this question here. I think my computer's having a moment where it's losing the plot, but it'll come back to the reality in a moment. Here's your next question. It says that a student is given these two equations, and they want to find the simultaneous solution or the intersection point of these two graphs. And then it says, which of the following is a correct line of working? And I want you to look at the options and tell me what you think is the correct line of working. It also says by using substitution. And so that might be a hint. Which of the four options do we think is the right one? Okay, a couple of different variations coming through. Keep it coming. So I was thinking this is the easy one, and I could sub it into the harder one here. So I'm going to leave a space, and then I'm going to put 5 minus 2x. But now this doesn't match any of them. So what do I need to do? What would I normally do if I was solving this? I feel like I would probably multiply out. I mean, it would be the most logical thing. So I'd multiply that out, and then I would get 3x plus 10 minus 4x equals 15. And at that point, I go, hold on, I think I see that one over here. And so the correct answer is B. Cool. Okay, so what have we done so far? We've looked at how we can find intersection points or simultaneous solutions using a graph. We've also looked at how we can do it using algebra. And so the types of equations we're having to solve are getting a little bit harder now. So let's go and find something that is up to your level here. So I'm going to give you these two functions, and I want you to find me the intersection points or the simultaneous solution. So find intersection points for these two graphs. And I want you to do it by yourself and then pop the answer in the chat. However, if you get stuck or you're feeling like you're lost, then pop that hand up or pop a message, and me or Label will come and assist you. Oh, is the screen not showing? So I think maybe it's just a momentary lapse on the internet, because I think my screen is still showing. It might just be on your side. Now, when you've got your X values, you can just pop them in the chat. Oh, I lost an X squared there. If there are any questions about how I got from here to standard form, then please do ask. You can either use the formula or you can use factorizing at this point. Let's see if I can do this. We have to. And whether you use the formula or factorizing, you should get the same answer. So I get X is a half, or X is 1, which Tova, Mpilo, Ngani, Toboko agree with me. Now, to get the Y value, what do I need to do to get the Y value? Because I've got the X's, but remember, a simultaneous solution or an intersection point has two parts. It has the X part, but it also has the Y part. And I want to say, I'm not going to grab the hard one. I grab the easier of the two equations, and I simply take that X value and get a Y value by putting that, so 3 times something plus 7. And over here, it's 3 times something plus 7. That something is a half here, that's 1 there. So that's going to be 8.5. And this is going to be 10. And so that's 8.5, and that is 10. So those will be my intersection points. So in reviewing, what have we done? So step number 1 was substituting into the one equation into the other and eliminating a variable. Step 2 was moving things around and getting it into standard form. Step 3 was solving the equation using whatever method you like. And step 4 was just making sure you had the Y values that came with it. And that's pretty much it. Again, let's have a little class vote. Thumbs up if we're feeling good about the process. Even if we're rusty still, you can see where we're going. Thumbs down if you're feeling ish. This feels like it's very new to me. Okay. The good news about intersection points or simultaneous equations is when you've done enough of them, they become quite repetitive, and then it's just easy marks in the bag. But that's the goal. We want to get you to the night. I want to get you to the point where I'm boring you with simultaneous equations. Then I know I've done my job. Okay, so that's our goal. Okay, let's have a bit of a break because we've worked for half an hour already. So what I want is I want everyone to stand up, turn on your cameras, and make sure that you are on your feet. I know that you probably feel a bit like, why do I have to get up? But we just know that we're humans, and so we need our bodies to move. It's just part of the learning process. So even if it feels a bit strange, get up from your chair, force yourself, and start by just shaking out a little bit. Look at that cool shadow I have behind me. Woohoo! Like Peter Pan or something. Okay, here we go. And
Please
shake
turn
out
on
your
your
face.
cameras, guys, and see your lovely faces.
Do like a little puppet show. Right?
Mr.
Okay, roll your shoulders. Roll your shoulders. Roll them back. Roll them forward. Okay, then let's stretch our muscles like this. Stretch the other side. Okay, and let's do a little bit of a rotation, but nice little rotation to start with. You just start spinning from your waist, and then as you feel your body relaxing, you can just go further, and then you should feel yourself loosening up. Okay, let us do something to get the blood and oxygen moving in our bodies. And we are going to do the skipping, but today we are doing it on one leg. So choose, actually let's do 15 on one leg, and then we're going to switch, we do 15 on the other leg. So standing on one leg, I want you standing on one leg, and I'm on my right leg at the moment, and we are going to do 15 virtual skips, and then we're going to switch to the other leg. Okay, in 3, 2, 1. 1, 2, 3, 4, 5, 6, 9, 10, 11, 12, 13, 14, 15. Switch to the other leg, and 1, 2, 3, 4, 5, 6, 10, 11, 12, 13, 14, 15. Oh, it actually felt quite cool doing it off each leg. And then I hope that your body is feeling from the chair, brain. You can choose which one you want. The goal is to make 24, and the one, there's just 3 different varieties. Choose the one that you feel most comfortable with. So Singasipo, today's topic is, it's under functions, but I really wanted to focus on intersection points. It's called intersection points. And because it's like one of those things where it kind of brings in quadratic equations, and it also brings in functions. It kind of sits under 2 sections, really. So the name is on Watobe website. I just called it intersection points and interpretation is what this course is called, because we're going to be interpreting graphs and functions as well, and then intersection points is one of the things that you need to know how to do. Okay, let's have a look. So Paul, I feel like you have got the red one. So 8 minus 7 is 1 times 8 times 3 is 24. So that's perfect. Caitlin has said 6 plus 2 gives me 8. And then 5 minus 2 gives me 3, which gives me 8 times 3, which is 24. And Sonic has also got the red one. So, and Kitsaw, it appears, has got the yellow one. So Kitsaw has said 4 over 4 is 1. And then, what have we got here? We've got 9. I was thinking, Kitsaw, you go 9 minus 4 over 4, and then you have 9 minus 1, which is 8 times 3. So then we get 24. So the 4 over 4 is an important idea that Kitsaw spotted there. All right, and Teresa has also got 6 plus 2, 5 minus 2. That is perfectly correct. Well done.
Nicely done, guys.
Oh, and Issa's one is interesting too. Wow. So 4 times 9 is 36. 36 minus 4 times 3 gets you to 24 as well. So well done, everyone. That was great. We're going to like send you to the maths before Olympics. I'm not sure if there are, but we'll start them if we have to.
Creative.
Okay. So what I want to do next is I want us to solve simultaneously, or another way of saying it, find the intersection points of these two graphs, and I'm handing it over to you to try and do by yourself. And then I will come along once there are questions from students. See if you can use what you saw in the first half of the lesson to help you solve this. Maybe if somebody's feeling generous, you can pop what you think is the first step that people need to follow in the chat. If someone's feeling like they're feeling very giving today, they want to give some of their knowledge away, pop what you think is the first step in the chat. Yes, make y the subject of the formula. That is a good tip. So as long as you recognize that this is the easier of the two and you should work with this first, getting the y itself will make your life a lot easier. Let's see. I think having 6x plus 12 as an equivalent version of this one is very helpful for subbing that into here. Okay, so now the question is, what is the next step after we've subbed in? Step one was to make y, isolate y. Let's say step one was to isolate y. Step two was to sub in. What is my step 3 and 4 going to be? That's what you want to ask yourself. Nompilo has said multiply to the bracket. Nompilo, I agree, because the bracket's getting in the way of things. And sir, did we leave out the 5 from the 5y? Well, we didn't, because if you look at this, the 5 is still there. But instead of being a y there, we said, look, y is actually the same as 6x plus 12. So we're taking what y is in the first equation and we're putting it into the second one. And what that means is that we don't have any y's in this equation. We've eliminated y's. So we get that. And that's good, because once we only have one variable, it's possible to solve for that unknown. Okay, so now the next question is, okay, step 1 was isolate, step 2 was sub in, step 3 was multiply out. What's step 4 going to be? Standard form, yes. And Timba. Khomelo, exactly. So I like to have my x squared plus 4x minus 30x minus 9 minus 60 equals 0. And then to get standard form, I should have that. Now I need to solve that. Now, if I could factorize it quickly, I could just factorize it. But I think part of me feels like, oh, this is the formula, because the numbers are big here. So it's not easy to see how I would factorize this. So I'm going to say, look, it's a quadratic equation. I'm going to use this thing called the formula, because it can handle any number, no matter how big it is. And so if we do that, let's see. So we have minus 26, so minus 6. So minus b, in case you've forgotten what the formula is. That's what it looks like. So then I get minus 4 times 1. And on the bottom, we have 2a, which is going to be 2 times 1. Can someone just tell me what delta is? So delta is the value that's inside the square root bracket. And I wouldn't mind just having that value if you can pop it in the chat. What do you get for delta? And then from there we can work out our... Some of you are probably doing this in one step, but... What is my delta value that I get? If I get 26 squared minus 4 times 1 times minus 69, we get 952. Okay, so now 952 isn't a perfect square. Now, what that's going to mean is my answers for x are going to be a little bit messy. So I'm going to go 26 plus the square root of 952 over 2. And I suspect that that would be 28.43 based on what I'm seeing in the chat. And then on the other side of that, I'm going to get minus 2.43. Give me a thumbs up if you're getting 28.43 and x is minus 2.43 as your x answers. Okay. And so now to find y, we've kind of done this a couple of times, we sub it back into the original equation. You could choose either of them, but the one that I think will make life so much easier is going to be the one that I made simple at the beginning. So what we have is 6x plus 12. So this relationship is so much easier to use. And so what I'm going to do is I'm going to say y is equal to 6 times 28.43 plus 12. Actually, let me color code this correctly. So 12, or y would be equal to 6 times something plus 12, and that something would be minus 2.43. So let me know in the chat, what are you getting for the y values? So if you use, there will be a little bit of a difference. If you use 28.43 cutoff versus 28.4 and then using all the decimals, so there'll be some slight differences based on that. I'm seeing 182.58. And so depending on the rounding, you should be around 182, 183. So I'm going to go with 182.58 for this y. And then for the other y, what am I going to get? I'm going to get minus 2.58. Yeah. And so that was quite a tricky one. But in the end, our answers still worked out using the same process as before, even though the journey was a little bit longer. If we look at those steps, so step 1 was to isolate, step 2 was to sub in, step 3 was to multiply out, step 4 was standard form, step 5 was solve, and step 6 was to sub back in y. So that's the 6-step process that we followed. Okay, I'll give you a moment to take a screenshot if you want. But I want to squeeze in one more tonight. So I do want to give you time to do that. So let me move on. Take your screenshot now if you need it. And then let me choose another one. Let's do that one. So I want you to solve simultaneously for those two equations, or find the intersection points of those two equations. That's what I want you to do. And if you do have a question, pop up your hand and I can assist you. Okay, are there any questions? When you, yeah, seems like everyone's doing fine. Okay, so there's two ways you could have done this. The one is factorizing, the other is using the formula. Both of them get x is 4 or x is -3. Last question for the day is, what are the y values that complete the simultaneous equation solutions going to be? Okay. So as I'm looking at the comments, I'm seeing that the answers 421 and -30 would be the answers most students would get. And just to kind of go back to the very beginning, if we think about if we had a Cartesian plane, what that means is these two graphs would meet each other at -30, which would be probably -30 would be like here, let's say. That could be, so that would be where the two graphs met. And then another place where they meet is 421, so 4 across and 21 up, so maybe all the way up here. And so if I had a graph, I found them using the graph. But if I don't have a graph, then I have to use the algebra, which basically says the two graphs are equal at intersection points. Therefore, I can sub one graph into the other, eliminate a variable, and solve for the intersection points. Okay. Lebo, if you could please put the poll out to students so that they can give us some feedback on how they found the speed of the lesson. Are there any questions or comments anybody would like to make before we finish off for tonight? Are there any questions or things that you're uncertain of? The main goal tonight was for you to know that when we talk about intersection points, we find them using either the graphical method or using algebra. There are other methods of solving simultaneous equations. I've only showed you the substitution method. You can use whatever method you like as long as you're getting the same answer as me. And then in the next lesson, what we're going to do is we're going to look, if we want to find intersection points where it's not a straight line and a parabola, what happens if you've got a hyperbola and a straight line? What happens in those situations where you want to find intersection points, and how does this method get adapted for that? And also some interpretation questions. Okay. So, Kat, I do know what topics we're doing next term. They're pretty similar to, they're exactly what the CAPS document says. So we're following the CAPS document, and so we're doing a bunch of things. There's definitely sine rule, cos rule, area rule, and then there's also data and statistics, and then also probability. Those are the three topics that CAPS lays down for the third term. And so we'll be following that, and then we may do some extra top-up lessons on top of that as needed. Okay. Any other questions from the students of the land? Bongokosi, I see that there's a question there. Let me unmute Bongokosi. What's your question?
My question is that on the first equation,
Yes.
3x minus. So when I take it to the other side, is it wrong if I remove the negative y by multiplying by -1?
Aha. So did you do that? Like you multiplied everything by -1 and then you got that?
No, I first took the 3x to the other side.
Okay. So you
Yes.
had minus y equals -3x minus 9.
Yes, sir.
And then you multiplied by -1?
Yes, sir.
So then if you multiply that, you should get y on the side, and on that side, you would get plus 3x plus 9, which is exactly the same. So that's completely fine.